All right, today we're going to do something a little different. Think of it like an archaeological dig. We're about to decode a document that's the secret foundation for some of the most important software on the entire planet. So yeah, let's get into it. Seriously, just think about that for a second. We're talking about systems for air traffic control, or the power grid for a whole country, maybe even critical military hardware. These are systems where failure just isn't an option. So when the stakes are that high, where do you possibly begin? Well, the answer starts right here. Now, I know it might look like just another boring government document, right? But this thing, the Database Design Description, or DBD for short, this is the whole key. You could almost call it the Rosetta Stone for building completely bulletproof data systems. Now, to really wrap your head around what this document does, let's stop thinking of it as a bunch of rules. Let's think of it as something much more powerful, a blueprint. It's just like the architectural blueprints for a massive skyscraper. Before anyone even thinks about pouring concrete, every single beam, every wire, every single bolt is meticulously planned out and specified. The DBD, it does the exact same thing, but for data. Okay, so let's get a little more specific. What exactly is this blueprint, according to the people who wrote it? The official definition sounds pretty simple, doesn't it? It describes the design of a database. But wow, that one little sentence is doing a lot of heavy lifting. This document becomes the single source of truth that every single person on a project refers back to. And here's what that really means in the real world. This isn't about creating paperwork for the sake of it. It's about total clarity. It guides the programmers, sure, but it also means the person testing the code and the person who has to maintain it 10 years from now are all working from the exact same playbook. It's all about preventing those tiny misunderstandings that can snowball into, well, catastrophic failures. Before you can get lost in the weeds and the tiny details, you have to sort out the big picture. And the DBD forces teams to answer the biggest, toughest questions right from the very start. Just look at the structure here. It's so logical. It builds from the ground up. You start broad with the scope and overview. Then you make those huge database-wide decisions. And only then do you drill down into the nitty-gritty of the data and software design. And finally, you tie everything back to make sure you actually built what you said you were going to build. And these big decisions, man, they are huge. We're talking about the fundamental architecture of the whole system. Is the data all going to live in one place, or is it going to be spread out? What's the plan for backups? And more importantly, how do you restore everything after a disaster? How do you make sure the data is always, always correct? These choices get made and locked in right here, so there's absolutely no confusion down the road. Okay, so this is the part where the DBDD goes from just being a smart planning document to something else, something truly remarkable. This is where the magic really is. Because, let's be honest, anyone can come up with a big idea. But to actually execute it perfectly, especially when things get complicated, that takes a level of precision that feels almost obsessive. And that is exactly what this blueprint demands. And here you go. This is pulled straight from the standard. I mean, just look at this list. This isn't some high-level summary. This lays out the specific things you have to define for every single piece of data in the entire system. Let's really break down what that means. So think about this for a second. For just one data field, let's say altitude, you have to define its name in plain English and its technical name. You have to define its unit of measurement. Are we talking feet or meters? You define its valid range of values, because altitude can't be a negative number. You define its required precision. How many decimal places do we need? And you define who's allowed to see it or change it. Now, imagine doing that for thousands, maybe tens of thousands of data elements. That's the level of rigor we are talking about here. It's wild. And if you thought that was detailed, get this. The document even defines its own words with just painstaking precision. This quote is a perfect example. It's all about killing any chance of ambiguity. When they use a word like data element, there is absolutely zero doubt about what they mean. The goal is to create a perfectly shared, crystal clear language. Okay, so it's incredibly detailed. It's maybe a little overwhelming, right? But what's the payoff? Why on earth would anyone go through all this trouble? Well, the difference couldn't be more stark. It's night and day. On one side, without a DBD, you get chaos. You get ambiguity, which leads to bugs, security holes, and systems that are an absolute nightmare to maintain. But on the other side, With the DBD, you get precision, reliability, security, and a system that's built to last. It's the difference between building your house on sand versus building it on solid bedrock.
And really, this is the main takeaway. When you see a process this detailed, it's so easy to just write it off as useless red tape or bureaucracy. But it's not. In these high-stakes worlds, every single one of those detailed requirements is a safety check. It's a way to find a potentially disastrous error on paper long before it has a chance to cause a disaster in the real world.
And that kind of leaves us with one final big question for the future. As we hand over more and more of our decision-making to automated systems, to AI, does this kind of super careful, human-driven design become less important? Or does it actually become the most important thing of all? Definitely something to think about.